Good morning, all of you. In the last lectures, we just finished the one characterization technique of nanomaterial, that is X-ray diffractions technique. So the main aspect of this nanomaterial, that is the characterization technique of your nanomaterials. Once you prepared the nanomaterials, so there is very need or important to characterize the nanomaterials. So the characterizations of nanomaterials in terms of the size of nanomaterials, their morphology of nanomaterials, and atomic level, or this some other important features of nanomaterials we can characterize with the help of different techniques. So out of this many techniques, in your syllabus we have to just cover up the three techniques only. That is, one is the X-ray diffraction, second one is the same scanning electron microscope, and third one is the TIM, the transmission electron microscope. That is the microscopy. Okay, so these are the three techniques which is only cover in this topic, but rest of the remaining very important characterization techniques are available for the nanomaterials, right? So from these techniques, we just give the informations, or these techniques just provide the informations about the morphology, structure, size, and atomic level of this nanotechnology, nanomaterials, right? So friends, in XRD or XRD diffractions techniques, we know that the XRD diffraction techniques, it is the simple techniques. We pass the electrons, or we pass the wavelength of that electrons, and which uh, interacts with your sample, and then they, some part of this light, or this wavelength, it is absorbed. Some is the reflected, and some is the scattered. So the scattering of light, and there made the angles between these samples. And when we were taking an examples of the rotating crystals methods, so that time you were this sample you are rotating by the mounting table. So that rotations, and that due to the mounting tables, your samples different sizes or different sides, it interacts with the wavelength, and then the scattering lights made the angles between this incident and reflected, or this scattered light. So that scattered angles we just pointed out with the help of photographic plates, and that is the working. We know that working of this X-ray diffractions. And due to this interactions, we just understand the Bragg's equations. So that Bragg's equations we are using to calculate the lattice parameters, right? So from this lattice parameters and all this information which is given by the Bragg's equations, and the your X-ray diffractions, which is on the basis that we can conclude it, the what is the geometry of your materials, what is the size, or what a little bit about the morphology of your material. So that kind of informations are given by the X-ray diffractions techniques. Now we just understand the same, that is a uh, scanning electron microscopy. So before that, the scanning electron microscopy and your the transmission electron microscopy, there is involving, that is the electrons involving, but it is a microscopy. So friends, electron microscopy means what? Is this just a basic understanding? We should know the what is mean by the microscopy. So there is a two kinds of microscopy are there. One is the optical, and second one is the electron microscopy. So this electron microscopy is very similar to this optical microscopy. Only the some basic difference between these two microscopy, electrons and the optical microscopy. For example, in optical microscope, the electromagnetic radiations of a proper wavelength are used, and it's focusing this radiations, and for the scattered radiations, and glass lenses are used in the optical microscopy. But in electron microscopy, instead of electromagnetic radiations, electrons are used. And instead of glass lenses, here we are using the electrostatic or electromagnetic lenses. So this is the basic difference between electron microscopy and optical microscopy. And rest of the things will be same. So as the electron exhibits the wave particle in nature, that is we explain with the dual equations like lambda is equals to h upon mv. So this is the de Broglie's equations explain your light is wave or it is particles like that. So the duality we just know that. So why these electrons were using? Because the electrons having the wavelength, it is very small range, that is 0.001 to 0.02 nanometers. So the energy, so the which depends on the energy of this your electrons. त्याच्यावरती तुमच्या इलेक्ट्रॉनची एनर्जी काय आहे depends. So due to the smaller wavelength of electron, so that electrons we are using in the electron microscopy, and that is the uh, that energy of electrons in the electron microscopy can be used to image the tiny particles. Okay. म्हणजे जे काही सॉलिड मटेरियल्स आहेत त्याची इमेज काढण्यासाठी दिस इलेक्ट्रॉन्स अँड देअर वेवलेंथ इट इज व्हेरी इम्पॉर्टंट अँड देअरफॉर this electron microscopy or we are electrons is used in the electron microscopy. And what is the principle of electron microscopy? Electron microscopy, it is a simple interactions of electrons with the solid materials. Is complicated due to the charge on electrons and due to interactions of electrons with the ions in a solid. So this is a simple principles. सो आता हे सिंपल प्रिन्सिपल्स का आहे कारण इथे सिंपल इंटरॅक्शन होते एकदा तुमचं लाईट्स किंवा इलेक्ट्रॉन्स त्यावरती इंटरॅक्ट झालाय सो नाव your electrons are interact with the sample, so your sample it is solid in nature, then there is a reflection, absorptions and scattering, this phenomenon which will be happen in a sample, right? So that the simple phenomenon, that is the interaction of electrons with the solid materials. And then after the interactions, then there is a complicated uh, phenomena which will be happen is there, that is due to the charge of electrons. See, that complications which will occurs because of the your electrons having a charge, and due to interactions of electrons with the ions in a solid material. So solid materials it may be in ionic form, so that is the reasons to complications will be occur, right? So what complications and what kind of phenomena which will occur in a after the electrons are bombarding on your sample. So that time, so this is the simple figures which will be just to understand what kind of phenomenon occur after the interactions, right? So once your electrons beam is interacts with the, here is your sample, this is the one of the tube, that is a tear shaped volume interactions, or this is electrons beam which is bombarded from these directions on the your sample. And after the interactions there is a phenomenon just like the scattered electrons, second one is the back scattered electrons, third one is the this x-rays, this is will also happen x-rays. Now this is the top of your sample surface, right? And this is the tear shape volume interactions. Tear shape means your after the interactions of your electrons with the sample, so this kind of the interactions only happen, so that is a tear shape volume interactions. Tear shape volume interactions means just like your umbrella shape. So this tear shape means just like a umbrella shape interactions, this is the umbrella shape interaction, right? So this is simple phenomenon which will occur in a your sample cell. Due to this interactions of electrons with the sample, tear shape volume of interaction is formed, and this when electron is interacted with the surface of the solid materials, many phenomena such as the back electron, that is a scattering, back scattering of electron, production of secondary electrons. This is the very important things because it is also this secondary electrons which is important and it is play an important role in our microscopy. and the productions of X-rays, and it may takes place of this X-ray phenomenon also, or it is production of this one. Beam of electron should be focused on the sample surface without getting scattered or deflected by air. So electron microscopy requires vacuum. So this is very important things. If you use the electrons microscopy, that is your beam of electron, that part should be vacuum, because due to the air, your electrons, there is a possibility your electrons may be scattered, or your electrons may deflected. So there is a very needful things, that is your path of your beam of electron should be vacuum. तो व्हॅक्यूम असणं गरजेचं आहे. तिथं कुठल्याही पद्धतीची एअर असता कामा नये किंवा गॅस असता कामा नये. जर तसं असेल तर तुमचा इलेक्ट्रॉन्स काय होईल, सॅम्पलवर स्ट्राईक करण्याच्या आधी त्या गॅसवर किंवा एअरवर होईल आणि तो डिफ्लेक्ट होईल किंवा तो स्कॅटर्ड होईल. So the result of your interactions will not be fruitful, right? So this is all about the basic aspect of electron microscopy. So on that basis, your scanning electron microscopy, it is totally based on this phenomena. इलेक्ट्रॉन मायक्रोस्कोपीच्या या फिनॉमिनावर किंवा या सगळ्या याच्यावरतीच तुमचं स्कॅनिंग इलेक्ट्रॉन मायक्रोस्कोपी आधारलेलं आहे. So this scanning electron microscopy, which is the short form of this microscopy, it is called as the SEM. Okay. So in 1933, this invented the electron microscopy by German scientist, that is the Ruska. For this invention, he was awarded the Nobel Prize in the physics in 1986, right? So what is the this is a one kind of instruments. The same is one instrument, and which gives the or the provide the informations about the structure and morphology and the different types of the characterization parameters of your nanomaterials. So simple construction and working of your scanning electron microscopy, that is same consists of electron source, just like your electron microscope, obtained from the tungsten and lanthanum hexaborate cathodes filaments. So this is the tungsten and lanthanum hexaborate cathode filaments is there, and this is the source of your electrons. जे तुमचे इलेक्ट्रॉन्स कुठून येतात, तर या टंगस्टन किंवा लॅन्थॅनम हेक्साबोरेट कॅथोड फिलामेंट्स पासून तुमचा सोर्स आहे इलेक्ट्रॉनचा. ओके, सेम इन्स्ट्रुमेंट्स मध्ये. नाउ दॅट सोर्स इट इज सिम्पली कॉल्ड ॲज अ इलेक्ट्रॉन गन. सो तो जो इलेक्ट्रॉनचा सोर्स आहे, बीम ऑफ इलेक्ट्रॉन्स आहे, विच इज कमिंग फ्रॉम दिस टंगस्टन अँड लॅन्थॅनम हेक्साबोरेट कॅथोड फिलामेंट्स. सो दॅट इज सिम्पली कॉल्ड ॲज अ इलेक्ट्रॉन गन. त्याला आपण इलेक्ट्रॉन गन असं म्हणतो. ओके. Now, the tungsten is used as electron gun because it has highest melting point and lowest vapor pressure of all the metals. टंगस्टनच काय यूज केला जातोय इलेक्ट्रॉन्स बंबार्डिंग करण्यासाठी ऍज अ सोर्स म्हणून, तर त्याचं कारण हे आहे की तो खूप जास्त मेल्टिंग पॉइंट त्याचा आहे. म्हणजे तिथे कितीही हीट क्रिएट झाली किंवा टेम्परेचर असेल किंवा समथिंग इज डिफरंट, सो इन दॅट कंडिशन्स दे आर स्टेबल. म्हणजे त्याचा मेल्टिंग पॉइंट हायेस्ट आहे म्हणून तो स्टेबल असतो, आणि लोवेस्ट वेपर प्रेशर ऑफ ऑल द मेटल्स. सगळ्या मेटल्स पेक्षा त्याचं जे प्रेशर, वेपर प्रेशर असेल ते कमी असते. म्हणून टंगस्टन हा सुटेबल मेटल्स आहे फॉर द यूज एज अन सोर्स ऑफ अ इलेक्ट्रॉन गन, राईट? The electrons emitted has energy between the few thousands electron volts to the 50,000 electron volts. सो दिस इलेक्ट्रॉन्स, आता जे काही इलेक्ट्रॉन गन त्यामधून बाहेर पडतात त्याची जी एनर्जी असेल ती किती असू शकते, तर इट इज कम अप टू दिस 50,000 इलेक्ट्रॉन व्होल्ट. दिस मच अमाउंट ऑफ एनर्जी दे हॅव युअर इलेक्ट्रॉन्स. ओके. So a beam of electrons is focused by two successive condenser lenses into a beam of very fine spot. आता हे जे इलेक्ट्रॉन्स जात असतात ते दोन वेगवेगळ्या फोकस्ड बीम मधून किंवा त्या फोकस्ड सक्सेसिव्ह कंडेन्सर लेन्सेस मधून ते पास होत असतात. त्याची फिगर आपण पुढे बघूया. अँड आफ्टर दॅट इज स्ट्रायकिंग ऑन युअर सॅम्पल्स अँड पॉइंटेड देअर फाईन स्पॉट. The beam of electron is allowed to pass through पेअर्स ऑफ स्कॅनिंग कॉइल्स. आता हे जे दो बीम ऑफ इलेक्ट्रॉन्स आहे हे कुठून परवानगी देतात त्यांना पास होण्यासाठी, तर ज्यामध्ये पेअर्स ऑफ स्कॅनिंग कॉइल्स विच डिफ्लेक्ट द बीम linearly or in a roster way through the object lens. सो जी ऑब्जेक्टिव्ह लेन्स आहे त्या ऑब्जेक्टिव्ह लेन्सवरच ते जाऊन पडायला पाहिजे, म्हणून तिथे स्कॅनिंग कॉइल्सची अरेंजमेंट केलेली आहे. त्याच्यामधूनच ते जातात आणि डायरेक्टली आपल्याला ज्या लेन्सेसवर त्या इलेक्ट्रॉन बीम पडायला पाहिजे त्याच लेन्सेसवर तो पडतोय. तिथून स्ट्राईक होऊन तो तुमच्या सॅम्पलवरती पडतो. So this kind of simple constructive arrangements and they're working in a same, right? ओव्हर रेक्टँग्युलर एरिया ऑफ अ सॅम्पल सरफेस. आता जो रेक्टँग्युलर एरिया तुमचा सॅम्पल सरफेसचा असतोय तो ओपन असतोय आणि वन्स युअर इलेक्ट्रॉन्स आर स्ट्रायकिंग ऑन दॅट युअर सॅम्पल मटेरियल, देन इट्स फॉर्म अ टियर शेप phenomenon or tear shape scattering or tear shape phenomenons is observed. Okay, so this is a simple original instrument of your scanning electron microscope, and which is given by this fellow. This is the first same which is given by this Van Andren. And in 1942, the first same for the bulk sample which is used. Okay. So after then, this instrument is commercialized. Okay. This component of the same, this is the electron gun, this one is the electron gun, this is the electron beam. This electron gun madun आपले electrons bahar padtayet. This is a simple path. These are the two arrangement or two lenses over here, and this is the magnetic lenses. Okay, instead of the glass lenses, we are using here magnetic lenses because your electron should be straight. It is passing through this one, right? Now here the secondary coils is there. This secondary coils is there. It is allowed to pass your electrons from the secondary coils, and then the base here is the BSC detectors, and here is the stage that is your sample is there. So after these samples striking of your electrons over here, it is this is the tear shape phenomenon. This is the tear shape phenomenon. That is the secondary electrons, the X-rays, and the scattering electrons over here, right? So this is the source of electrons beam which is accelerated down the column. Then a series of lenses which act to the control the diameter of the beam as well as the focus which beam of the specimen, right? A series of this aperture, this one, which is the beam passes through this which affect the properties of that beam, your electrons, right? An area of this specimens interaction that generates the several phenomenon like a tear shape phenomenon over here. So after the productions of secondary electrons, scattered electron, backscattered electrons, X-rays, so this type of signals that can be detected by process to produce the image or the spectra. एक्सरेचं जर तुम्ही प्रोसेस केलं तर तुम्हाला एक्सरे मिळेल, एक्सरे डिफ्रॅक्शन स्ट्रक्चर मिळेल किंवा त्याचा स्पेक्ट्रा मिळेल. बॅक स्कॅटर केला असेल तर त्याचा वेगळा स्पेक्ट्रा मिळेल. तुमचा secondary electrons असेल तर त्याचा वेगळा. So it is depends upon the what kind of signals we can detect it and we can process with this signals, and that kind of a spectra we can obtain, right? So all this above which maintain at a high vacuum level. So this all the instruments it is maintain the high vacuum. इथे तुम्हाला vacuum पाहिजे. Without this vacuum, your electrons cannot be passed through the state, right? Your sample. It can be detected or it can be scattered. Here is also the simple schematic diagram of your same. That is, here is the vacuum pump because it's create the vacuum all the your instruments. This one is the your electron gun, and from this your electrons beams are passing. Here is the first condenser lens. That is the condenser lens. This one is the condenser lens, and this condenser lens it is very important things because we are passing electrons beam through this one. It maintain their the path as a path to maintain करते. Okay, this first and second condenser lens. Then this here is the deflection coils. that is where using the deflection coils. And this is very important rules to objective lenses, that objective lenses which is deflected your beam and on your sample. This is your samples and it is deflected your beam on this your samples. After these deflections we can recognize the different kinds of the tear shape phenomenons or the signals. Here we are using this one, the backscatter electron detector. Here we are using the X-ray detectors. Here we are using the secondary electron detectors. So these electrons, the striking on this and the signals we can detect it with these three detectors. Okay, X-ray detector, secondary electron detector, and the backscatter electron detector. So this is a simple schematic diagram of your SEM. This is also the one of the image informations of the SEM schematic diagram. So the electron guns and this one is the this striking on your samples and this detectors, and the detector give us the signals to the your the amplified, and then it comes to the image on your computers. So this kind of this one. Now what is the exactly work of your SEM? तुमचा सेम कशा पद्धतीने, आता आपण इथं इलेक्ट्रॉन गण आहे तो पास होतो इथून इलेक्ट्रॉन्स इथे. here is the your two lenses are there, that is condenser lenses 1 and 2. Here is the some magnifications control, that is the your coil is there, and then some here is your samples. After the interactions of your samples there can be detected by the detectors. So three kinds of detectors are there. Okay. So this is the final aperture. So once you are past the electrons beam towards the samples, and then the phenomenons observe the tear shift like a phenomenon, and then we here the three kinds of detector is there, the secondary X-ray and the backscatter detector is there, and then once you recognize your signals then it's amplified and comes to the your computers, and computer display your spectra. Okay. So what is the exact work of your same instruments? The same instruments uses electron instead of a light. We know that this, and in the form of this image, we can, the electrons are very important things in a same. A beam of electrons is produced at the top of the microscope by hitting of the metallic filaments like your tungsten. The electrons beam follow a vertical path. This one is the vertical path to the column of the microscope. This one is the microscope. This is your instruments and it is a vertical path. It makes it way through the electromagnetic lenses. Here is the electromagnetic lenses which is deflected your electrons towards the specimen or your sample. It makes its way through the electromagnetic lenses which focus and direct the beam down toward the sample. This is very important role of your magnetic lenses. Once it hits the sample, other electrons are ejected from the sample, and detector collect the secondary backscattered electrons, scattered electrons, and converted X-ray also. So converted them into the signals that sent to the viewing screen like your computers. Once in gives the signals and it recognize your signals into the computers, that time your spectra we can observe as an image, right? So this is the simple working of your SEM. तुमचं सेमचं अशा पद्धतीने वर्किंग करत. So see, this is the your tear shape scatterings, tear shape phenomenon, all interactions of your electrons. So this is the electrons which is incoming electrons over here. Here is the sample is your place over here, and after this interactions between your electrons and sample, this tear shape, that is the umbrella shape of your interaction is happened, because the after the interactions of your electrons, this kind of electrons is back ejected electron, that is a backscatter electron. This is the secondary electrons, this is the auger electrons, this is the X-ray electron, this is the cathode luminescence. So all the kind of electrons are ejected after the interactions of electrons, and therefore this is called as a tear shape electrons or tear shape volume interactions. So Once you electrons recognize this one, recognize this one, recognize this one, recognize this one, recognize this, so the corresponding the signals recognize the corresponding spectra will observe. जर तुम्ही हा रेकग्नाइज केला नाही, याचा जर प्रोसेस केला, तर तुम्हाला ऑर्गर इलेक्ट्रॉन्स किंवा ऑर्गर स्पेक्ट्रोस्कोपीचं स्ट्रक्चर मिळेल. ओके. एक्सरे जर तुम्ही रेकग्नाइज केला, त्याला जर हे केलं, तर तुम्हाला एक्सरे चा स्पेक्ट्रा मिळेल. कॅथोड ल्युमिनेसन्स केला तर तुम्हाला तो ल्युमिनेसन्सचा स्पेक्ट्रा मिळेल. बॅक स्कॅटर्ड इलेक्ट्रॉन किंवा सेकंडरी इलेक्ट्रॉन्स हे केला तर तुम्हाला सेम मिळेल. सो इट इज ओनली डिपेंड्स अपॉन when the accelerated beam of electron striking of your sample then penetrate inside into the depth of the about 1 micrometer. सो 1 मायक्रोमीटर पर्यंत हा इलेक्ट्रॉन्स काय होतो, या सॅम्पल मध्ये आतमध्ये पेनिट्रेट करतोय तुमच्या सॅम्पल मध्ये, अँड देन इंटरॅक्ट बोथ द इलास्टिकल अँड इनइलास्टिक्स विथ द सॉलिड. सॉलिड मध्ये इलास्टिक अँड इनइलास्टिक जे काही मटेरियल्स किंवा इलेक्ट्रॉन्स असेल त्याच्याशी तो सॅम्पल्स इंटरॅक्ट होतोय, then forming a limiting interactions volume from which various types of the radiations are emerges or the electrons will be observed, and therefore we can recognize this different kinds of the uh, radiations which will observe, that is the backscattered, secondary, auger, X-ray and cathode, and therefore it is called as the tear shape volume interactions. Tear shape volume interaction. So this is a very important things in your SEM. See here, this is the your one tip of your SEM. Here is the your surface of your sample, and then this laser beam of your materials, and they simply observed this kind of samples. तो फक्त आपण इथून टीप फिरवत असतोय, या सॅम्पल वरून तो फिरवत असतोय, अँड देन different places we can observe the different types of the images of your सेमच्या वेगवेगळ्या इमेजेस का दिसतात, तर हा टिप जो असतो तुमच्या सेम इन्स्ट्रुमेंटचा, तो फक्त आपण या सॅम्पल वरून काय करतोय, वेगवेगळ्या ठिकाणी फिरवत असतोय, अँड देन वी ऑब्झर्व द डिफरंट टाइप्स ऑफ द सेम इमेजेस और द सेम स्पेक्ट्रा, राइट. सो दिस इज व्हेरी इम्पॉर्टंट थिंग्स अबाउट द युअर same. So this primary electron striking the surface of your samples, they are inelastically scattered by atoms in the sample. तो inelastically जर हे होत असेल तर प्रायमरी इलेक्ट्रॉन हा inelastically त्यामधून स्कॅटर्ड होतोय, and due to this scattering the primary beam spread and fills the teardrop shape volume into the surface, right. So which is happen in the sample material, and due to this interaction the subsequent emissions of the electrons, that is emissions of the secondary electrons takes place. त्यामधून तो सेकंडरी इलेक्ट्रॉन्स आणि बॅक स्कॅटर्ड इलेक्ट्रॉन्स आणि स्कॅटर्ड इलेक्ट्रॉन्स बाहेर काढतोय. एक्सरे ऑल्सो वी कॅन बी रेकग्नाइज ऑल्सो देअर. They are detected to produce an image. Once we the signals can be recognized, and then we can detect the or produce the image or the spectrum. So the X-ray are also produced when the electron interact with the samples atoms. There, the detections with the dispersive X-ray spectroscopy by this which compositions analysis of the sample can be done. So this will be the happen in the your same instruments. तुमच्या स्कॅनिंग इलेक्ट्रॉन मायक्रोस्कोप मध्ये हा अशा पद्धतीचा फिनॉमिनॉन किंवा ही वर्किंग स्टाईल त्या इन्स्ट्रुमेंटची आहे. अँड प्रायमरी इलेक्ट्रॉन्स स्ट्राईक होते, देन सेकंडरी इलेक्ट्रॉन्स आर observed in the recognized or the spread into the samples, that is the drops or the tear shaped volume, and that is X-ray, secondary electrons, back scattered electrons, and the X-ray. So these are the signals which we'll observe, and then we can uh, obtain the images of the different style, right. The very important thing is that how the sample is prepared for the scatter characterizations to the towards this instruments. या इन्स्ट्रुमेंट सोबत तुम्हाला जर तुमचा सॅम्पल कॅरेक्टराइज करायचं असेल तर सॅम्पल प्रिपरेशन आज व्हेरी इम्पॉर्टंट. जसं एनएमआर जर तुम्हाला तुमच्या सॅम्पलचा घ्यायचा असेल तर एनएमआर हा तुम्ही जसं डायरेक्टली सॅम्पल दिलं आणि ते केलं तर असं होत नाही. तर तुमचा सॉलिड मटेरियल असेल तर फर्स्ट युअर सॅम्पल इज डिझॉल्व इन टू द सुटेबल सॉल्वंट. तो सुटेबल सॉल्वंट म्हणजे एनएमआर मध्ये तुम्हाला जर हे असेल तर CDCl3 वर मध्ये CDCl3 जर असेल ड्युटेरेटेड सॉल्व्हंट जे असतात त्या ड्युटेरेटेड सॉल्व्हंट मध्येच तो डिझॉल्व्ह करायचा असतो अँड देन दॅट सॅम्पल प्रिपरेशन्स विच टेक इन टू द युअर इन्स्ट्रुमेंट, असं एनएमआरचं आहे. तसंच सॅम्पल प्रिपरेशन इज व्हेरी इम्पॉर्टंट फॉर द सेम. So what is the sample preparations? The sample required for the sames to be completely dry. So dry असायला पाहिजे. It required a high vacuum and for living cells, tissues and soft body organisms require chemical fixations to preserve and stabilize their structures. म्हणजे जर तुम्हाला केमिकल्स यूज करायचे असेल तर इट शुड बी ड्राय. पण जर तुम्हाला लिव्हिंग ऑर्गॅनिझम्स असतील, लिव्हिंग सेल्स असतील, टिश्यू असेल किंवा सॉफ्ट बॉडी ऑर्गॅनिझम्स असेल तर पहिल्यांदा त्याला केमिकल फिक्सेशन्स करायला पाहिजे की जेणेकरून त्याचं स्ट्रक्चर किंवा त्याची स्टॅबिलिटी ही आहे तशीच प्रिझर्व्ह राहील. आणि जर तो इन्स्ट्रुमेंट समोर आला तर त्याच्या इलेक्ट्रॉन्स एनर्जीमुळे तो डिस्टर्ब होता कामा नये. सो फर्स्ट यू हॅव टू फिक्सिंग दिस the living organism or tissue or something soft body materials will chemical fixations and for their preservations or their stabilizations they do not change their structures in while you are doing this characterization techniques. So this is very important things about the same. Then about the living organisms and tissue like this, insulating sample cannot be used directly. So that insulating sample we cannot use in the same instrument directly. So such as solids are coated with the thin metal film. म्हणजे पहिल्यांदा त्याला काय करायला पाहिजे, इन्सुलेटिंग पासून कंडक्टिंग मध्ये आणायला पाहिजे. इन्सुलेशन जर असेल म्हणजे तो इलेक्ट्रिक करंट पास करत नसेल तर त्याला पहिल्यांदा त्या फॉर्म मध्ये आणायला पाहिजे. सो त्यासाठी आपण काय करतो, वी आर युझिंग टू कोटिंग ऑफ अ मेटल फिल्म. मेटल फिल्मची त्याच्यावरती कोटिंग आपण त्याला देतो. And then this solid materials we are using as a sample. Amplifiers are used to amplify the signals and backscattered electrons and secondary electron. आता जे काही amplifiers असतात, so you should check the amplifiers. There is a recognizing the signals like backscattered electrons, scattered electrons, and the secondary production is electrons. So that kind of the checkings it's needed for the sample preparations of your SEM. So SEM मध्ये ह्या चार गोष्टी खूप महत्वाच्या आहेत. एक तर तो ड्राय असायला पाहिजे. जर तुमचं लिव्हिंग ऑर्गॅनिझम किंवा टिश्यू असेल तर त्याला केमिकल फिक्सेशन्स करायला पाहिजे जेणेकरून त्याचं स्ट्रक्चर किंवा स्टॅबिलिटी डिस्टर्ब होता कामा नये. त्यानंतर इन्सुलेशन, तुमचं जे सॅम्पल हे इन्सुलेटर असेल तर त्याला पहिल्यांदा मेटल फिल्मनी त्याला कोटेड करायला पाहिजे की मग त्याचं इन्सुलेशन निघून तो कंडक्टर मध्ये येईल आणि मग त्याला आपण सॅम्पल यूज करू शकतोय. आणि जे अँप्लिफायर आपण यूज करतो, जे सिग्नल रेकग्नाइज करतात, इट शुड बी चेक अँड they can recognize the backscattered electrons, scattered electrons and the productions of secondary electrons. एवढेच त्याने काय करायला पाहिजे, रेकग्नाइज करायला पाहिजे, राईट. सो बिकॉज if it is recognized the luminescence, auger and the x-ray, the jambling which will be occurs, तिथे मग खूप गोंधळ उडेल आणि त्यामुळे आपल्याला एक्झॅक्ट स्पेक्ट्रा मिळणार नाही. सो युअर एम्प्लिफायर शुड बी रेकग्नाइज और इट शुड बी एम्प्लिफाय द सिग्नल्स ओनली the productions of secondary electrons, backscattered electrons or the scattered electrons only, not x-ray, not luminescence and augers electrons, secondary electrons cannot be signalized or the amplified with your amplifier. So these are the very important things for the sample preparations of your SEM. Okay, then some advantages and disadvantages of your SEM. The first advantages of your SEM, that is it is very first methods to obtain the image of tiny particles. Tiny particles ची इमेज देणारा हा पहिला इन्स्ट्रुमेंट आहे किंवा कॅरेक्टरायझेशन टेक्निक आहे. सेकंड ऍडव्हान्टेज आहे दॅट इज इट इज यूज फॉर द बायोलॉजिकल सॅम्पल अँड इट इज नॉन डिस्ट्रक्टिव्ह मेथड्स. ही नॉन डिस्ट्रक्टिव्ह मेथड्स आहे बायोलॉजिकल सॅम्पल साठी आणि सुद्धा हा यूज करता येते. ओके, म्हणजे तुम्ही जर एखाद्या लिव्हिंग ऑर्गॅनिझमची सेल घेतली ती सुद्धा आपल्याला त्याची इमेज काढता येते न डिस्टर्ब होता. दिस इज व्हेरी important advantage. Disadvantages of this semi, it can not be used for the non-conducting materials without coating treatment. म्हणजे एखादं नॉन कंडक्टिंग मटेरियल असेल तर त्याला विदाउट कोटिंग ट्रीटमेंट आपण त्याला यूज करू शकत नाही. सो दिस इज व्हेरी इम्पॉर्टंट थिंग्स. सो फर्स्ट यू हॅव टू कोटिंग वेअर नॉन कंडक्टिंग मटेरियल. Then second one, this method is cannot be used as atomic level, म्हणजे सेम ही atomic level वरती यूज करता येते. So these are the advantages and disadvantages of your SEM. जे ॲडव्हांटेजेस म्हणजे टायनी पार्टिकलची इमेज हे देतोय. सेकंड बायोलॉजिकल सॅम्पलची सुद्धा आपल्याला डिस्टर्ब न करता इमेज देतोय. डिसएडव्हांटेजेस आहे की नॉन इन्सुलेटर्ससाठी याला आपण यूज करू शकत नाही. पहिल्यांदा त्याला कोटिंग करायला पाहिजे आणि नंतर त्याला यूज करायला पाहिजे. सेकंड वन, दिस मेथड्स कॅनॉट बी यूज्ड ॲज अन एटॉमिक लेव्हल. एटॉमिक लेव्हलवर ही मेथड यूज करता येत नाही फॉर द कॅरेक्टरायझेशन टेक्निक.